All right. All right. So we all are here for our project number 5, and that I am picking as dengue case prediction. Well, again, it's related to healthcare. It's a healthcare project, and I want to introduce this term dengue, which is a viral infection in humans that's transmitted to humans through bite of affected female mosquitoes. Okay, and the name of the mosquito is Aedes. It is a major public health problem in tropical and subtropical regions worldwide. If we do talk about the areas here in India also, most probably after rainfall or during rainfall, such kind of cases rises. In every city, such kind of cases related to the dengue rises. Okay, so what are the causes of dengue? As I already told, that it's a viral infection and which is due to bite of a female mosquito, and there are four distinct but closely related serotypes of the dengue virus. It can be like 1, 2, 3, and 4. These are the types. Okay, these are the types of virus in dengue. It's much more related to a medical term, but whatever we can understand as the domain knowledge for the dengue, we are trying to understand. Okay, so infection with one virus provides lifelong immunity against that specific serotype, but not against the other. This means that if a person is infected up to 4 times in their lifetime by different serotypes of the virus, subsequent infection with a different serotype can increase the risk of developing severe dengue, known as this particular kind of fever. Since we are having four types of virus, four version of dengue fever, how it will be known that I am affected by this one or this one or this one or this one? This is much more related to medical terminology, depending upon the lab reports and everything. Okay, it's saying that still a person can be infected up to 4 times in a lifetime. Why 4 times? Okay, one time by this, one time by this, one time by one time, up to 4 times. It can be affected at most. Rest, it will build up an immunity towards it. Okay, dengue transmission, if we say, it is primarily spread through the bite of infected mosquito, Aedes mosquito, and if this mosquito bites a person, virus is injected in the bloodstream. This virus then multiply in the whole body, causing illness. If another mosquito bites the infected person during this particular phase, it can become infected and continue the transmission cycle. See, I don't know whether we have an idea about that. For example, you have been bitten by a infected mosquito. In your blood, the virus is present. If any other mosquito which was not infected, but if it bites you, now that mosquito will also become infected. What is the reason? The reason is virus. We talked about no COVID also, virus. So virus replicates. It spread in your body. Also, the one who's taking it will spread in that also. So mosquito become infected by biting a person who is already that virus in its blood. This is how the transmission occurs. The symptoms of dengue. Okay, the time between the bitten of the infected mosquito and the appearance of symptoms, that is 4 to 10 days. High fever, headache, pain behind the eyes, joint and muscle pain, fatigue and the weakness, noise. And these are common symptoms. In viral fever also we do have these symptoms, normal viral fever. Malaria also we may have. Dengue also we are having. So unless and until we don't have a lab report, we can't finalize that what is having. Okay, however, skin rash, bleeding can help in identify what could be. In some cases, dengue can become severe, like abdominal pain, vomiting, rapid breathing, severe bleeding, fluid accumulation, organ impairment, drop in blood pressure. There are many things can possible if it is in a severe case. Diagnosis, okay, we do have some tests related to the dengue like IgM, IgG to detect the antibodies present. Okay, so we can have a test related to it. We can have a PCR test also. We can have antigen test also. That means our antibodies are building against to fight some virus. So we can have such kind of test also to identify. Okay, what could be the treatment? There is no specific antiviral treatment for dengue. So, management focus on relieving symptoms and prevent complication. Treatment includes fluid replacement, maintaining proper hydration, pain relief like paracetamol and everything, aspirin, non-steroidal like this, monitoring patient. So that's why a dengue patient are kept separate. Okay, dengue patients are kept separate from the normal patients just to avoid the transmission. Okay, this is the reason because we don't have any specific antiviral treatment for dengue as per the knowledge mentioned, the terms mentioned. I know the dengue patients are kept separate. So we can have fluid replacement like maintaining proper hydration, something pain relief medicines can be given and monitoring can be done. Okay. For prevention of dengue, okay, vaccination. Although some vaccine exists, prevention mainly focus on mosquito control. Why? Because you have already seen the points clear. Treatment we don't have like anything specific. We can control the mosquito. That is why it has been told that the water deposits जहाँ पे larva है और ये जो भी कुछ है whatever the things are they say कि deposition should not be there because these kind of your mosquitoes and this kind of virus not develop at that particular place only. Okay, mosquito bite eliminating, you can have some solutions for that. Insecticides you can apply. Okay, you can use mosquito repellents. Okay, oil, lotion, something like that. Using mosquito net, wearing protective clothing, and vaccination can be done so we can have safeguard against the dengue. See, if I talk about the impact of dengue, so about dengue is endemic in over 100 countries, the most cases occurring in Asia, Latin America, and Africa. Dengue affects about 100 to 400 million people annually, with 500,000 people developing severe dengue and about 20,000 deaths each year. Okay, so in urbanization, rapid urbanization, there will be Aedes mosquito because of the water sources. Global warming, global travel, virus will also travel. Okay, so climate change, particularly the rise in the global temperature and unpredictable precipitation patterns, may be a reason for Aedes mosquito growth. Okay, so we have to keep the surveillance, and the research is going on for dengue prevention. Okay, how we can save ourselves from the dengue. We are looking forward for new vaccine, antiviral treatments, and mosquito control. There are many things. The government come up with some plan. They give the instructions, and we have to follow it. So, in this project, we are going to perform the dengue case prediction with the data. Okay, and what is available in our data. Here is the data description with me, and let me show you the Excel sheet also, what is available with us in terms of data. So I am sharing the entire screen now, and please check the data sheet. So this is my data. You can see there are many features available in the data. Okay, like first one is the serial number. So serial number is a continuous number. I don't have anything to say about the serial number. Then I am having temperature max. So the temperature max is the maximum temperature recorded for the day. It can be in degree Celsius, it can be Fahrenheit, it can be like anything depending upon the region. So temperature max is the maximum temperature. Temperature fluctuations can impact mosquito behavior and breeding, potentially affecting dengue transmission. Okay, so temperature is one of the important parameter. We are having minimum temperature also recorded for the day. Lower temperature can limit mosquito activity. So this can influence the spread of dengue. Okay. If temperature is more, it is impacting, and temperature is less, it is limiting the mosquito activity. Okay. Then we are having one more column, temperature, that is the average temperature recorded for the day. So we have included the max, we have included the min, we are also including the average temperature. It plays crucial role in mosquito breeding cycles and incubation period for the dengue virus within the mosquitoes. Okay, so temperature is an important factor for us here. So we are seeing how mosquito develops with this temperature. There's an impact of temperature on the process of dengue virus, Aedes mosquito. We are having feels like max as one of the column. Temperature for the day, feels like temperature, which accounts for the factors like humidity, wind, in addition to the actual temperature. Feels like means we are having factors like humidity and wind also. We are incorporating them. Okay, so here in my data sheet, you are having all the numerical values: max temperature, min temperature, temperature, that is average temperature. Then we are having feels like temperature also, which incorporates humidity, moisture, pressure, whatever be the things are, they are included here. Okay, and then we are having feels like minimum. So feels like max. Okay. So in max, now it gives a sense of how hot they felt, which might influence human and the mosquito activity. Again, we are talking about the mosquito activity only. Minimum also. feels like minimum temperature, impact on mosquito behavior. Feels like is the average feels like temperature, providing overall measure of how hot or cold they felt, accounting the humidity and the wind. We are having dew. The dew for the day is the temperature at which air becomes saturated with the moisture and water vapor condenses. Saturation in the air. Okay, condensation process. So higher dew points often indicate higher humidity levels, which can create favorable condition for the mosquito. That's why I told just after rainfall, if there is a humidity, I think we have connected this point just recently in a practical scenario. After rainfall, there is a humidity in the atmosphere, water condensed. It is a favorable condition for the mosquito to develop. And because of that thing only, because there is a technical reason for every question. So, since we are having a favorable condition for the dengue mosquito develop, obviously the cases will go into rise. Humidity, that means the percentage of humidity in the air. Precipitation, that means the rainfall recorded during the day. See, these put an impact. Temperature, humidity, average temperature, all are putting impact. That means environmental conditions are full on responsible for dengue mosquito. Okay, so precipitation, rainfall. Rainfall can create standing water, which serves the grounds for. I already told you this thing. Standing water. If you are having water deposits, they are the source for spreading the dengue transmission. So don't let the water storage. Precipitation, precipitation probability. So it's in percentage. This feature predicts the likelihood of rain. So probability of rain, that is precipitation, precipitation probability. Precipitation cover, that means a portion of the day expressed as a percentage that experience the precipitation. That means that means your rain for a day. How much rainfall occurred in a day? What percentage of rainfall occur in a day? That leads to more standing water and which affects the mosquito breeding. Snowfall, the amount of snow recorded during the day. This feature is less relevant to dengue transmission as mosquitoes thrive in warmer climates. It might prevent, okay, it might prevent, okay, in the snowfall, but there might be chance that according to the geographical locations, we are including this feature also. That is snow. Snow depth also, like for example European countries and all, they are having snow. So snow depth, that means the present of snow on the ground. Wind speed recorded during that day in meters per second or kilometer per hour. Wind direction in which it is blowing, measure in degree, from true to north, from true north or whatever. Okay, so this might affect mosquito dispersion, although it's less directly linked to the dengue. Okay, not directly linked, just these are the environmental conditions we are putting. They're not directly linked to the dengue. Okay, then sea level pressure measured in millibars, changes in the pressure. As the weather changes, the pressure changes, which may be indirectly affect mosquito breeding. Cloud cover, that means the percentage of cloud during the day. Okay, how the clouds are present. So cloudy days, cooler temperature, higher humidity conditions could affect mosquito behavior. Visibility, that means hog or something like that. Okay, so how much you can see, how much miles you can see, visibility. This feature is less directly related to the dengue. It's just a part of weather condition. solar radiation, amount of solar radiation received during that particular day, like watts per square meter. Higher radiation may indicate sunny day, which can influence mosquito activity and human exposure outdoor. If it's a sunny day, so people will come out of their houses, they do work. In rainy day they are inside. Sunny day they have, so it's more exposure. Solar energy received during the day often measured in kilowatt hours. UV index, that means ultraviolet radiation from the sun, which is not directly related to the dengue transmission. It's just a part of outdoor effect, influence the outdoor activity. Conditions like summarizing the overall weather condition, like it is rainy, sunny, cloudy, whatever it is. Stations, that means identification of the code of weather station that recorded the weather data. That means the location, something like that. 25 cases, the number of dengue cases recorded on a particular day and location. This is our target. Okay, so we are available in this particular data. See, labels is just like low, medium, and high. Okay, category. Okay, however, in our case, it is just normal. Only one is present, normal. So we are not going to keep this as a target. Our target is dengue case prediction. So in this particular data, we have seen the environmental factors. Okay. In the environment, the most impacting factors are temperature, humidity, precipitation, like rainfall, and these are the factors which are important. Rest, we are having some more factors related to our wind speed, wind direction, snow, and all these things are present. UV rays and other things. They are not directly related to the dengue. They are indirect. They may have indirect. It depends upon the exposure of a person for the dengue spread. So dengue spread because of this environment only. If you are having a water depositions, if you are having a larva where the dengue virus can spread, and if it's been present nearby you, you are in danger. And obviously, as I told that it requires special treatment for dengue patients. Okay, it comprises of four type of virus: one, two, three, four, and we don't have anything specific. You will be kept separate. Dengue, for dengue people, separate. All right, and you will be paracetamol, and this all medicines will be given. So special attention to this particular, and we are having right now this season, especially rainfall, and I gave you the reason. It's mentioned in our data set. So apart from data science project, we got to know some more things related to this particular disease. So as I shared the data set like this is our data set. All the factors which I have mentioned are available in this data set. You can see my data is much more numerical in nature. That's what something keeps us interesting. And we are having continuous feature more. That is more interesting. Okay, having continuous features in our data, that that's something good for analysis. So all this temperature, minimum, max, and everything are continuous in nature. We do have snow and snow depth, they are zero, entirely zero. I have seen entire zero. And we are having label is normal only. And these are the cases, dengue cases. We are actually predicting the case only, dengue case prediction. That's what we are doing. Okay, so you can see this is our mostly numerical data. Continuous features are there. Okay, with environmental factors. So now, if you understood the data, the point is you should proceed ahead. with the implementation part. The approach, you very well know, there is nothing like to build up an approach. So far, we are doing the same thing like importing the library, doing the EDA part, visualization part, pre processing. That's all we are doing. That's a common approach. Okay, and because case are continuous in nature, so obviously we have to use regression algorithm. This is also clear. Regression. In regression, we can apply ML algorithm, we can apply DL algorithm for regression. That is also clear. Okay, so let's see how things goes. So dengue case prediction using machine learning, including deep learning also. Here are the necessary libraries as I proceed with the same stuff. Okay, which will not create trouble for anyone. These are the libraries. Okay. Then warning, importing the data, dengue data. Then EDA. Already shown you the data and whatever be the features mentioned, I already explained. So EDA printing the head, tail, shape, rows and the columns, and column names in the data. Okay. Serial is just a sequence number, so I don't care for the serial. I'm dropping it. I dropped serial. There are no duplicates present in the data. Every entry is unique. There are also no null values in the data. That's what we have to check. No null values, no duplicates. Information if I print, so all are floating point, integer point, only the label is object type. Rest all are numerical values. This is information. Description I printed, okay. It's a statistical description. Count, mean, standard deviation, minimum, maximum, everything I printed. Okay, these are the number of unique values present in the data. Okay, these are the unique values. Since we are having the numerical columns, so mostly unique. Okay, then this is the approach to classify the data. Every time I do in my project, and you know the pattern how I follow. And this helps me to perform the quick analysis, quick interpretation, and quick project building. If you are having a flow, it doesn't matter what kind of data present in the world, any kind of data present in the world, you have an option to work on it. Okay, fine. So yes, object type, numerical type, classification, discrete, categorical, non-categorical, everything done. Fatafat, finishing this thing. Then I have seen that I am available with only one label. I am having zero value for the snow and the snow depth. So I don't have any kind of specific analysis for these two. The only analysis which I should be doing is related to the continuous features because they are more in my data. So it's better, let's get started with continuous only. Draw the histoplot, histogram. You can see I am having something looking to be normal temperature max, some skewed data also. This is left skewed. Understand it. Left skewed because tail is on the left. So left skewed. This is also left skewed. This is somehow what left and so on. So histogram for the continuous feature. Similarly, I will be making distribution plot also for the feature. Every feature I will be making to check the distribution. How the plots are there for how the distribution is for the features. Then I made a box plot to check the outliers because my data is not that much high. So definitely I am not going to drop any outlier from my data. Let me keep them here. Let me keep. the outliers present in the data. There are some outliers present in the data, but let it be. I made box plot till box plot is fine. Boxen plot and Wallin plot are the optional plot. If you want to keep, you can. If you don't want, remove. These are optional. So whatever information I required, I got it. In univariate analysis for continuous by making histogram, dust plot, and box plot. Then for bivariate, I applied continuous versus continuous scatter plot to see the relationship between how two features are behaving. Are they related? Are they not related? Okay, so here it is. You can see, yes, there is a relationship between temperature and the temperature max. You can see a line. So, what I am looking here in this particular case, I am looking the behavior of the features x1 and the x2. This behavior can be like this, or either it can be like this. If it is having like such kind of points between x1 and x2, then there is no relationship between x1 and x2. No relationship. This is direct relationship, this is inverse relationship. So such features are correlated features. These features are not at all correlated, and that's what I want in my models. Least correlated features. Okay, so with the scatter plot, you are going to identify which are related, which are not related. So I made the scatter plot between each and every feature, every to every. This is negative correlation. Humidity versus temperature max. You can see the points are coming down. Okay, no correlation here. Precipitation and temperature. Here also no correlation. Precipitation, probability, temperature. So here you can check out the relationship. And if you want the numerical interpretation of this, obviously we are having the correlation matrix, CORR. We can find the numerical value for it. Anyways, I made the scatter plot, and you have one more option. You can make line plot also. Continuous versus continuous, you can make line plot also. Scatter plot I made, that is easy. Line plot, it will take more time for building. You can make this thing also. Okay, fine. So done. Then I used then I used discrete, unique. That means snow and the snow depth. I am having only 0, 0. These values only. Value counts also I checked 60 to 602, both 0, 0. I don't have anything to do for them. Categorical I am having only normal. Okay, only normal, and I can have value counts also for that. I think I missed this thing. Value, value counts. Okay, for I in categorical DFI. Okay, maybe it's now because my code is entirely executed now. So if you re-execute this thing code, this code you will get it. Okay, and then I made bar plot between categorical and it's just an optional. I don't have any option present here. It's optional thing. So label versus each and every continuous feature to print the average value. These are the average value. Average temperature against the label is 31.92. Either you can avoid this plot, it's not mandatory. Okay. Then I decided to have a pivot table. So in pivot table, I took label as an index and rest things I took as a value, and I calculated the mean. Okay, so normal 31.45 feels like max 38, and so on. These are the average values for normal for these specific features. Okay, I took precipitation snow also. I calculated the average values. Okay. These also I calculated. For wind speed and wind direction also, with respect to categorical, I took wind's direction and these are the average values. So like this, now you can make the pivot table for getting the insights over the data. Okay, categorical against the numerical values by picking the aggregate functions mean, max, min, sum, etc. You can do that. So I made this pivot table. I am having so many environmental conditions, I took separate. Solar separate, temperature separate, wind direction separate. All these things I took separate. Okay, fine. These are the average number of cases. Fine. So, yes. So, this is what I got. And then I calculated the correlation between the features, between the continuous features. Correlation. We have already tried to monitor this thing using scatter plot. The scatter plot just show you a plot. It will not show you any numerical value. With correlation, I can identify the better because I can make a heat map. This is your heat map, and heat map will tell us the correlation exactly. Okay, so by seeing the numerical values, we found that there are features which are correlated, and in this particular regards, I have kept a threshold of 0.65. It's up to you how much threshold you want to keep. In the previous project, I took the threshold of zero point 0.7. Here I am keeping threshold of 0.65 because it's up to you how you analyze the correlation. I have seen that many of the feature are showing the correlation around 0.69, okay, 0.66, 0.67. So I think if such kind of correlation exists, and if I don't drop this feature, maybe my model will get overfitted. Maybe. There are 0.72, some features are correlated like this way. Okay, so anything beyond, see, I am having so many features, and we don't want to get trapped in curse of dimensionality. There is one more issue. If you are training a model with so many number of features, then you will be trapped in curse of dimensionality because of overfitting, obviously. So I kept a threshold 0.65. Anything beyond 0.65, out. Please, out. Don't keep such features. So here is the code which I prepared. Like I wrote 0.65 threshold, and then here I prepared an empty list, the features to drop, and here I calculated what features I need to drop. I check the correlation between each and every feature. In any feature which is having high correlation, more than 0.65, drop it. I actually appended them in a list. In this list, I appended them, and then these are the features which I got. Temperature feels like max, feels like min, feels like dew, cloud cover, solar energy, UX, UV index condition. So these are the features which I got, which are correlation, showing correlation. So I dropped them. Okay, that's what I did. Dropped. I am having label. See, label is one of the feature present in the data. You may say that sir, snow and snow depth, they are having all zero value. Why you are not dropping them? You are keeping. See, I am keeping them because I want to take care of the location of any location also. If someone will ask how the dengue will affect in a snowy area, then what should I answer if I drop them? Though they are having zero values in my current data set, but at least keep. Okay, so label I can drop, but let it be, it is having only normal value, just keep it, create a dummy, keep it. Also snow and snow depth, all zero values are in there. Let's keep it, don't drop. Okay, so this is my data set, 17 features. Okay, the one which I need to drop because of correlation, collinearity, I did. Okay, and then obviously, huh, I need to use the regression algorithms for this particular project. I mean to use linear regression, support vector regression, decision tree regression, random forest regression, XGBoost regression. As a machine learning algorithms, traditional, and I want to use deep learning also, I will be making neural network for this. Okay. So the requirement of support vector regression is scaled data. The requirement of linear regression is normalized data. There will be one parameter here to be evaluating a model is R2. And I was talking about R2 in my ML class. This explaining someone R2 is also complicated. You can explain MSC easily. Mean square error explanation is very easy. You can explain. That's a major criteria for evaluating a regression model. But explaining R2 is challenging. Why it is challenging? I hope we are having the experts here present in the session. They might be knowing this thing. Okay. This is quite challenging to explain the R2 score because R2 score, okay, yes, they were said, so it's challenging because R2 score tells about variance, variance explained. R2 score is high doesn't mean you are suitable it for model. No, if R2 score is high, because in case of regression analysis, remember, in case of regression analysis, we are having to evaluate two things. One is error, one is R2 and adjusted R2. Error, predicted minus actual. R2 I am seeking, I'm telling you variance. R2 actually means that how much training features are contributing in predicting the value of Y. That is what R2 means. How much these features are responsible to predict the value of Y. That is R2. Its reference range is 0 to 1. The formula for R2 is 1 minus summation of yp minus y cos square divided by summation of y minus y bar cos square. This is R2 score formula. So it is 1 minus error cos square divided by variance cos square. ये error है ना, this is error and this is variance. This is the formula for R2. Adjusted R2 we use to penalize R2 if it is showing overfitting. So that is adjusted R2. It consider the number of features and also the number of samples present in the data. That's what it comprises of. Okay. So these are the things which we have to see in our data. So if I want to use SVR, I need to scale my data, standard scaler. Scale my data. Let me tell you very frankly, being a data scientist person, machine learning person, deep learning person, generative AI person, normalization, standardization, or you can say scaling, transformation, linear algebra, which comprises of matrices and the vectors. These topics are very, very much important because they are applied in every scenario of data science, machine learning, deep learning, and generative AI. Every scenario they are applied. If you are not using these terms in the pre-processing of the data, your definitely model will fail. Definitely model fail if you are not using it. पॉसिबल ही नहीं है आपका मॉडल सक्सेस हो जाए जब तक आप डेटा के ऊपर यू आर नॉट अप्लाइंग दीज थिंग्स एज पर द रिक्वायरमेंट एज पर द अजम्पशन यू विल फेल मैट्रिक्स तो गजब ही है मैट्रिक्स एंड वेक्टर्स बिकॉज यू रिप्रेजेंट योर डेटा इन फॉर्म ऑफ मेट्राइसेस एंड मेट्राइसेस आर हैविंग मेनी ऑपरेशंस आपको करना ही पड़ेगा ये काम whatever be the architecture you are learning seeing metrics. Okay, fine. So, yeah, that's the scenario. I am left with the model development part. Here I did scaled my continuous feature and I put my support vector regressor and other algorithms here. Okay, so, okay, I want to close